Hi Year 11, welcome to your video tutorial. This video tutorial is intended for students completing the Stage 6 Software Engineering syllabus, first unit of work Programming Fundamentals, and the very first syllabus dot point, Software Development. Information and images gathered in this presentation have been sourced from Software Engineering, the Year 11 course, unless otherwise stated. Okay guys, the fifth stage of the software development cycle is integration. So once the dev has gone on and actually coding the design into whatever programming language, the code needs to be integrated. So if that is in an agile environment, the current sprint may have to be integrated with other sprints that have already actually gone live. So you actually have to integrate or merge the code, or with other systems, even if it was being developed in an agile or a waterfall or structured environment, your code might have to be integrated with other legacy systems or other external databases or APIs. An important thing to understand in the integration stage of the software development cycle is that VC occurs, and it's version control systems, and they're used to change and maintain and track and maintain changes to source code. So a few concepts to get your head around here. The most popular VCS, and to be honest, in industry they're just called VCs, the most popular VC or version control is Git. Most people in industry use Git, and I'm about to throw 5 new subject-specific pieces of terminology at you. So Git's been around forever. It's made by a guy. Don't look at the Urban Dictionary for what Git means, but basically it's not someone who's very nice. And the guy who invented it pretty much named it ironically because he was a bit sick and tired of current existing version control. So Git is primarily a piece of software that is designed to manage and track changes in big software dev projects. Its particular focus, and the reason why I'm bringing it up here in relation to sprints and integrating code within existing code, is that Git is used particularly in agile development environments when you need to integrate new sprints into the existing code. So I'm about to drop 5 new terms for you: a repo or repository, commit, branch, merge, and pull request. So let's hang around for these ideas. Repo, when you push something to repo, it's the collection of files and their version history that sits within Git. When we're talking about commit in a Git environment or an integration environment, what that means, it's a snapshot of changes at a specific point of time. If you do a specific point in time that kind of have a unique identifier. A branch is a parallel line of development that allows isolated features or bug fixes to be worked on. A merge is the combining changes from different branches into one single branch. So basically taking all the different branches that have been worked on and merging them. And finally, pull request or PR is a proposal to merge different changes, and it's often used in like Git hosting platforms. So that's a whole lot of definitions. I'm going to give you a shot in the slides that actually has that definition for each of those. But in Git, these are terms. If you work in industry, these are terms that are going to get dropped every couple of minutes. Hey, my pull request failed. My merge failed. I need to hit commit. It's in repo, go find it. Those are words and those are phrases and new subject-specific terminology. It sounds like slang, but it is terminology that you will have to get used to. As well, I'll actually provide for you a little snapshot that has a breakdown of how Git actually works. So how these subject-specific key concepts or terminology that I've just dropped from you, repo, commit, branch, merge, pull request, how they actually work in a collaboration environment. And your teacher may choose to spend some time on this, or this might be something you need to do a bit of a deep dive into yourself later. For now, I do want to have a look at a couple of other key concepts in the integration stage, because this one is quite heavy. So the next concept in the integration stage is an API. An API think about it like a connector or an interfacer between two different applications. So it connects your application with something external. An API call or request, which includes input data, is sent to another system and the response is returned from the remote system. So basically think about an API as two hands stretched out and connecting two different systems. Okay, they work on a call and a response relay, which is what I've just gone over there. If you want, in the slides as well, I'll put a couple of examples of existing APIs that exist in our world and ways that people that can use them. So in terms of integration, you may need to look at API integration. So if you're reviewing this particular slide within Catholic Schools Parramatta Diocese, you may want to spend some time looking at the Compass API, which is actually publicly available from Compass, which can do some interesting stuff in terms of room changes and your timetable. So your teacher may choose to spend some time looking at that. Otherwise, you can do that. Webhooks are another way in terms of integration, but unlike APIs, they just work on one-way traffic. So you may need to do some integration with webhooks, but unlike two arms stretched out and constantly having that connection there in that two-way traffic, it's just that the one application or one external application gives you a notification if there's a change, and you can do that. You can have an integration with webhooks to notify you've changed to action other things within your system. And that might be something at this point in time that you have to look at integrating your code with. Another concept, which is, the next two concepts are a little bit older, but they still exist. DLLs, or Dynamic Link Library Files, is a part of Windows architecture, and it's a compiled module that contains functions and data that can be used by another application. It's still in use. It's a historical requirement that's now built into a lot of operating systems, particularly Windows. It's unfortunately an unavoidable aspect because of the way at which it was constructed. It was originally designed to speed up processing power, but now we're thankfully, cough cough, we are stuck with DLLs as an inherent part of Windows architecture. The last part, and this is more common than you would suspect, is that your code may have to integrate with legacy software. We often have to write updates in order to connect still to legacy software, and people and you would be quite surprised. I would suspect, that how much legacy software and how many high-profile systems all across our society, from traffic to retail to weather to emergency services, are actually underpinned by legacy software for which every update has to integrate new code with really, really, really old software. And that's it, guys. That's the integration stage of the software development cycle. So there's a lot of subject-specific stuff we've just gone through there. We've gone through Git, DLLs, webhooks, legacy, APIs. We've only skimmed the surface. If you wanted to do a deep dive into any of more of those things, there'll be further information and breakdown in the slide, particularly related to APIs and Git. And that's it. That's integration.